Okay, so now we're going to look at inverse trig functions, and we're going to look at the integration part. So make sure, alright, sorry, just making sure my pen's working. Alright, make sure, and I told you right here, memorize. Memorize these three formulas. You're going to need to know them. They'll be in your homeworks that you'll do from this section. They'll be on your quiz. They will definitely be on your exam, so make sure you have those memorized. They will not be given to you. Alright, so let's look at some examples on how to integrate. Alright, so look at the first one. Look at A. I want to integrate 1 over 4 plus x minus 3 squared. So you want to decide, alright, which one does that look like? Does it look more like that? Does it look like this one, or this one? Well, you can tell that it's going to be looking like the second one, okay, because there's no square roots. This one's easy to pick out, so this one looks like arctan. Okay, so now what you want to do is pick out the pieces, okay? So I always look at it, so this part that's going to be a squared. So a squared is equal to 4, which makes a 2, okay? All right, and then this part, well, that's u squared, okay? So that tells me that u is x minus 3, and then you're going to need du, and so du is just 1 dx. Okay, hold on, let me see if I can get this any finer. Okay. Alright, so we've got our pieces, and let me go back to this du part really quick. So u squared is x minus 3 squared, so u is x minus 3. So du, oh, much better, du is just going to be 1 dx. And when you're looking at it, you want to look and see, is that what I have? Well, if you look at it, we switch colors, alright, then yeah, that's exactly what I have. I have 1 dx. So there's nothing that I need to multiply in by, nothing that I need to fix. I'm good. So I can go straight to my answer. The answer, when you integrate that, it's 1 over a, and you can see I'm right here. 1 over a, let me erase all those arrows so you can see it. Alright, 1 over a arctan u over a plus c. So I just need to fill in. So 1 over a is 2 arctan of u, which is x minus 3, over a, which is 2 again, plus c. Okay. So there was nothing that I had to fix in this one, okay? Alright, let's look at this one. This one will have something. Alright, first thing I'm going to do is, if you notice, let me erase all this, all these formulas, the arcsine, the arctan, the arcsecant, when you're looking at them, they all have just a 1 du on top. So I'm going to take first thing and I'm going to pull out the 2. Alright. So you need to decide, alright, which one of those 3 does this one look like? Alright, and because of that x on the bottom, on the outside of the square root, that's going to be like this one. If it was a number, then it would look like the top one, the arcsine. But since it's an x there, we're going to say, alright, this is an arcsecant. Okay, so let's, again, look at the pieces, okay? Alright, so u, this is u squared. Okay, so that's u squared. So what would u be then? Well, u square 3x to get that 9x squared. So then du is 3 dx, which if you notice, that's not what I have, so I'm going to have to fix that 3. Okay, and then this right here, that's a squared. So if a squared is 25, then we know a is 5. Okay. So we got our pieces and we got it labeled out. Okay, so let's see. When I'm matching it up with the formula, okay, I need on the bottom, okay, let's do it again in green. I need u right here, okay, and I've just got x, and u is 3x. So if I put in a 3, you know, normally I would, and I've got it on the denominator, okay, normally I would cancel it out on the outside, but Also, on the top, I need du, and du is 3, and I have 1. So I'm also going to have to throw in a 3 up here. And because that 3 over 3 cancels out to be 1, I don't have to cancel it on the outside with anything. I'm good. I need to multiply in a 3 on the top and 3 on the bottom, so I'm good. Okay, so let me switch back. So now I have all the pieces that I need, and don't forget that you got that 2 on the outside. So it's 2 times, alright, and it's going to be 1 over A arcsecant absolute value of u over A plus C. So that's going to be 2 times 1 over A. So that's 1 over 5. So I'm going to go ahead and write it as 2/5. Okay, arcsecant of the absolute value of u, which is 3x, over A again, which is 5, plus C. So as long as you have your formulas memorized, these aren't hard to do. Okay, now the next few get a little more difficult. Alright, let's look at this next one. Alright, so I copied the formulas in again so we didn't have to keep going back and forth. Okay, so if I look at this one, on initial thought, when I look at it, I'm thinking, alright, well, it's going to look like arcsine. Okay, so if I started, then I would look and say, alright, well, A squared would be 4, which makes A 2, and then u squared is x squared, which makes u be x, which makes du be 1. And what's the problem? Okay, what's the problem when I look at this one? I have an x plus 2 on the top and not just that du. So I have this extra x up here. This extra, whole extra thing, this x plus 2. So it's not a straightforward arcsine. Okay, so when you run into this, there's going to be a couple of different things you can try, but right now what we're going to do when we run into this, okay, is we're going to separate this. So this is a trick I can try. I'm going to separate it into, sorry, I'm trying to write a little bit neater. Okay, an x over the square root of 4 minus x squared. Okay, dx plus, and I would think about writing the 2 right there, okay, over the square root of 4 minus x squared, but I don't want that 2 to throw me off, so what I'm going to do is go ahead and throw it on the outside and just do a 1. Okay, so now let me integrate these. Okay, so this second one, this is definitely going to be arcsine. I'm going to have everything I need, and it's going to be really straightforward. So don't forget how to do the first one. Remember, one of the first things that you ever try is to do a u substitution. Okay, so this is going back to one of the first things we learn. All right, if I let u be what's inside, you know, you're going to call that this. You're going to bring it to the top, and it'll be a negative 1/2 power. But we let u be the inside. So then du is just negative 2x dx, which is totally doable. I need a negative 2 right here, so negative 1/2. Oh, I don't know if you can read that. Hold on. Negative 1/2. Okay, so this becomes, alright, negative 1/2 times the integral. If I think about bringing that up, it would be u to the negative 1/2, and then I have du. Okay, so I've got negative 1/2 u to the negative 1/2 that I need to integrate it. So we are going to add 1 and get 1/2, and then divide by 1/2 is the same as multiplying by 2. So what happens with the 2's is they're going to cancel. So I just get a negative. Hold on, let me switch back. I get a negative u to the 1/2. Or a negative, you can go ahead and put it back in the square root actually. Negative square root of 4 minus x squared. Okay, so there's that one. I did not leave myself enough room. Okay, and then when I get ready to do this one, then this one now is that arcsine. So again, a squared is 4, so a is 2, and we've got u squared is x squared, so u is x, and du is just 1 dx, which is exactly what I have. So I can go straight to that formula, which is going to be, don't forget the 2 on the front, 2 times the arcsine of u over a, which is going to be x over 2 plus c. So if you put them both together, okay, are my two answers, okay. Sorry, didn't want you to think that was a negative. Okay, so if I put them together, I get the negative square root of 4 minus x plus 2 arc sine x over 2 plus c. So we're going to see that separation again in just a minute and try it with another one. Okay. Alright, and then sorry, I kind of ran out of room and it scrunched up right there. Okay, alright, so sometimes completing the square will help you when you get these quadratic functions, and so I made sure when you have to do your quiz that I told you to complete the square on this one. But you're supposed to remember it from algebra prerequisite material, but if you forgot it, I'm going to give you a real quick rundown. If I gave you something like this and I said, alright, complete the square, you're saying, alright, what do I add in? What is it that I add in to make this a perfect square trinomial, so then you can factor that as a binomial squared? So the way you get it is you take b, the number in the middle, okay, so in this one b would be 6, okay, but you take b and you divide it by 2 and then you square it, okay. So in this case b is 6, so 6 over 2, and I square it, well 6 over 2 is 3. So 3 squared is 9. So if I were to complete the square, what I need to add in is 9, so that then I can factor that into x plus 3 or x plus 3 squared. Okay. Alright, now that's what you do whenever it's a plain old x squared in the front, but what if there is a number in the front? You would have to factor out that 3. So if I factored it out, I'd be left with this. Okay, so again, I'm trying to say, all right, what is it that I would add in to both sides to end up getting something that I could factor and get a perfect square trinomial? All right, so again, you take the number in the middle, which is b, so negative 5/3. All right, and you half it, but instead of writing it as divided by 2, let's do it as, you know, divided by 2 or times what? A half. Sorry, having trouble with my pen. Alright, so we take negative 5/3 and we would divide it by 2, and divide by 2 is the same as multiply it by a half. Okay, so I get negative 5/6. So you take this, the number in the middle, and you half it, and then you square it. It's going to always be positive. Okay, that's why I wrote the plus there, because even if you had a negative like this one, when you square it, it goes positive. Okay. And so then when you get ready to factor it, it's always the number that you squared. Okay. But that's completing the square, and hopefully you are familiar with that from algebra, because we'll have to complete the square in these next problem. Alright, so we got something like this. Integrate 1 over x squared plus 4x plus 13, and right now it doesn't look like any one of my 3 inverse trig formulas that I'm looking at. Okay, so what I'm going to do is I'm going to complete the square. So I'm going to group the x squared and the 4x together, and I'm going to scoot this 13 down. Alright, and I'm going to complete the square with that x squared plus 4x. Okay, so remember, you take the number in the middle, the 4, okay, you half it, which is 2, and then you square it. And that's what you add in right there. So I can't just stick in a 4. Okay, I can't change my problem. If I put in a plus 4, I need to make sure I cancel that out with a minus 4, because if you put the two reds together, then you know you just get a 0. So you didn't change your problem any. Okay, so now what I can do is factor that into x plus 2 squared. And if I put the 13 minus 4 together, I get 9. And now this matches up great with an arctan. Okay, now if you look in the formula has the a squared before the u squared. The u squared is going to be the variable part. Okay, so if you would rather flip the order, you know, you can, that's fine. A is just going to be your plain numbers. Okay, the u part is your variable part. Alright, so we know that our a squared is 9, so that makes a 3. Okay, and then we're going to call u x plus 2. So du is just 1 dx, which is exactly what I have if you look on the top, 1 dx, so I'm good. So it's 1 over a arctan of u over a plus c. So if we filled it in, I get 1 over 3 arctan of u, which is x plus 2 over 3 plus c. Your book has some examples where they complete the square. Make sure that you look at those, and then let's look at one more. Okay. Integral of 2x minus 5 over x squared plus 2x plus 2. So again, you know, I would look at trying to complete the square with that on the bottom. And watch what happens on this one. This one's a little more difficult because you have to just think about it. This combines two of the things that we've talked about today. Alright, so first of all, let's just complete the square. Let's figure out what we need to add in. Alright, so take the number in the middle of the 2, the whatever's in front of the x, okay? So you would half it. Half of 2 is 1, and then you square it. You get 1. And then you know you're going to cancel that out, okay? So if I rewrite it, then I get integral of 2x minus 5 over x plus 1 squared. You're just factoring that. Plus 1. So again, this one really looks like an arctan. There's no square roots on the bottom, so I'm thinking, alright, in that order doesn't matter, I can flip it around. So even if I look at it like this, let's see what the problem is with this one. Alright, then I would call, you know, if that's 1, then if a squared is 1, then we know a is 1, and u would be x plus 1, but then du is just 1 dx. Alright, well, that's not what I have on top. I have that 2x minus 5. I can't do that, so this is where we're going to have to separate it, okay, like we did before. And I'm going to do a lot of erasing right here, because if you tried to separate it, okay, and if I said, alright, well, let me do the 2x with this. And even if I pulled out the minus 5. Okay, I'm okay with this one right here being an arctan. Everything matches up, but you know, this one it doesn't. And so even if I said, all right, well, let me play with this one a little bit. If I went ahead and multiplied out the bottom, it would be x squared plus, we just had it. So I get integral of 2x over x squared plus 2x plus 2. So if I look at that one and I say, alright, well, maybe I can do a u substitution like I did before. U is x squared plus 2x, and du would be 2x plus 2. Okay, I was thinking, oh, well, it was really close for a minute, but I need that plus 2 when I can't just stick in that plus 2. So, but that would work. And what I need is to get that plus 2 in there. I need for there to be, right here, I need there to be a plus 2. Okay. So what I need to do is I need to separate this better. I need to split it better than what I have. Okay? So, we'll go back right here. Right here. And hopefully this part's going to make sense to you. I'm trying to figure out the best way to show it to you. Alright. So, we've split it, and I need this, I need to take a plus 2 right here, okay? But over here, if we thought about it, there was that minus 5 on top that I just pulled out to the side, okay? But if I borrowed 2 from there and put it over here, I have to think about balancing that out with that minus 2 right there, okay? So this changes now to really be a negative 7, okay? And I'm going to write it here. Okay, so is everybody with me? I have this, 2x minus 5 on the top, and I'm going to take a 2x and a plus 2 on this side. Okay, but again, you can't just stick in a plus 2, you have to bounce it out. So then this side is left with the minus 5 and that minus 2. So there's where that negative 7 comes from. And then now this works great. Let me switch real quick. Alright, so we're going to let u be 2x plus 2, and then, not that. U is not that. Sorry. I'm getting a little bit ahead of myself. We know. We fill that back in. That was a negative 7. Okay, sorry. We are going to multiply out the bottom. And so we would get x squared plus 2x plus 1 plus that other 1. So we get x squared plus 2x plus 2. Now, then we're going to let u be the bottom. And then du would be 2x plus 2, which is exactly what I have. And so now I have du over u, but you know, I always say I like to write it as 1 over u and the du to the side. Okay, so I have 1 over u du, which we know that is integrates as the natural log of u. So the natural log of the absolute value of u, I'm going to go ahead, since I'm running out of room, and replace the u. Okay, and then over here, this is a great arctan with a being 1 and u being x plus 1. So du is just 1 dx, which is exactly what I have. And don't forget that negative 7 in the front, so that's a negative 7 times. And if you look at your formula, you know you're going to have it memorized. 1 over a arctan u over a, and then I'm going to have my plus c. So let's fill it in. So we get negative 7 times 1 over 1. So negative 7 arctan. There we go. Arctan. Alright, u over a. So that's going to be x plus 1 over 1. So we're just going to do x plus 1 plus c. Okay, so that one combined both the completing the square and that separating that fraction, so you can see both of those. All right.